right, so in this video, we are going to talk about the transformation called a dilation. So a dilation is when you enlarge or reduce the size of a shape. And when we do this, we create similar figures. So dilations create similar figures. So here on our coordinate plane, we have two triangles. And so the original triangle is triangle ABC. So it's the smaller one on the left. And then your new shape is the one that has these little apostrophes after the letters. So anytime you see those apostrophes, that means that that is the new shape. And we actually call this is A prime, B prime, and C prime. So our original is triangle ABC. Our new is triangle ABC prime. So we want to figure out how this shape was dilated. And so what we're looking for is what is the scale factor. So I kind of like to think about when we build houses, a lot of times constructors will have a blueprint of what the house is going to look like. And so they start with a picture or drawing on paper, and then obviously the size, once they build it, it's going to grow. It's going to get a lot larger because, you know, they can't put the size of a house on a piece of paper, and so they have to scale it. And so they do that. They enlarge the original image that they drew or picture, and they enlarge it so that they can actually make it come to life, and they know what dimensions the house needs to be. So that's what I think about whenever I think about a dilation, but that's just an enlargement. This is an enlargement because our triangle is getting bigger. So what we're going to do is we're going to find the scale factor. So we're going to find the scale at what the triangle is being enlarged by. And so just keep in mind that when you have an enlargement, your scale factor is going to be greater than 1. And if you have a reduction, meaning your shape is getting smaller, it's going to be a scale factor of less than 1. And when we represent this algebraically, right now we have ordered pairs on a coordinate plane that are just x comma y. And so when we figure out what the scale factor is, we can write the algebraic representation by writing the scale factor times whatever x is, and the scale factor times whatever y is. But we have to figure out what the k is in this situation. So to do that, we're going to look at these triangles, and we're going to write their coordinates, and we're going to see what is the relationship between our original and our new. And that's how we're going to find our scale factor. So first, let's look at our new shape, and I'm going to go ahead and figure out what these ordered pairs are. So starting with A, I notice that the x is 6 and the y is 3. So 6, comma 3 for A. For B, it is 15, comma 3. And for C prime, up here we have 9, comma 18. Okay, now we're going to look at our new, or our original image. So A is at 2, comma 1. B is at 5, comma 1. And C is 3, comma 6. So first we're going to go ahead and list our ordered pairs for our new and original image. The next thing we're going to do is we're going to figure out what the scale factor is. So now what we're going to do is we're going to find the scale factor. And to do that, we are going to compare the new coordinates of the new image to its original. And you can find the scale factor by picking any value and point to compare from your new to original. So I'm just going to go ahead and start with the x value. So if we look at the x value for point A, in the new image, the x value or x coordinate is 6, and the x value for A prime is 2. So here we're comparing the new coordinate to the original, and we get 6 over 2, and this simplifies to 3. And you can pick any coordinate that you would like and compare the new to original, and you should see that it has the same scale factor. And that's only if the shapes are similar to each other. Because if they're similar, we know their angles are congruent and their sides are proportional. And so I'm going to go ahead and just check another one. Let's pick the y coordinate for C, point C. So for the new image, the y coordinate for point C is 18. And for the original, the y coordinate for point C is 6. And 18 divided by 6 is 3. So this means that my scale factor is 3. 3 is larger than 1, and the shape is getting larger, so that makes sense. This is an enlargement. So when we want to write the new rule for this dilation, our x and our y value is being multiplied by 3, by a scale factor of 3. So we would write 3 times x and 3 times y. This is our new, or this is the way we can algebraically represent this dilation. We're multiplying the x and y by 3. So again, to find your scale factor, we're going to pick a coordinate for our new and original, and we're going to compare them, write them as a ratio. Then we simplify that ratio and we find the scale factor. Once we know the scale factor, we can say, okay, it's being multiplied by 3. We can write it algebraically here, and we can also verbally describe what's happening. And so to write our verbal description, so I'm going to go ahead and write for my verbal description that this is an enlargement by a scale factor of 3.